It's time to tackle some application problems, and we're going to do this using the technique of solving a quadratic by factoring and then applying the zero product property. Let's get right to it. So, a town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. So before I even continue, I'm going to actually draw that field, and I'm going to label the given information. 400 by 600 meters. The town wants to double the area of the field by adding the same amount to both the length and the width. Find the new dimensions of the field. So it's increasing both the length and the width by the same amount. And I don't know what that amount is, so I'm just going to call it X. And it's going to double the entire area of the field. So there are several ways you can tackle this, but one of the things I do is I write it into words, where I say that the new area is equal to twice the old area. If it's doubling, that would be a true statement. And then I'm going to consider, well, how do I write that area? The old area would be rather simple. Since it's a rectangle, we do 400 times 600. And I need to double that, so I'll have 2 times 400 equals 600. And the new area, well, I need to consider my dimensions. So the side was originally 600, but it gains x units right here. So this entire side will now be 600 plus x. Similarly, this one was 400, now it has an x added on. So I need to multiply these two binomials together. I recognize I have a quadratic here because I'm going to have x times x, and I'm going to try to put this into standard form. So go ahead, double distribute, FOIL, use the box method, whatever your choice is. When I double distribute, I get the polynomial on the left and 480,000 on the right. So I'm going to move this over to the left and reorder my terms so they are in standard form. So looking at this, as I go to factor, I know I need an x here, an x here. Since I have a negative 240,000, I'm going to make one positive and one negative. And just to help your brain think this through, 240,000 and you need the sum to be positive 1,000. So you might struggle a little bit with all these zeros at the end. Off on the side, I start thinking it through. I'm like, okay, so your common multiples of just 24 would be 8 and 3, 6 and 4, 12 and 2, and of course 24 and 1. Now, there are certainly more factors of 240,000 that I'm missing, but since I know I need them to add to 1,000 in the middle, when I look at these, if I make one of them negative, I'm thinking this combination here of 12 and 2 I can get to add to 1,000. Okay, so what do I mean by that? Well, like if I made this be a negative 2, 12 plus negative 2 is going to be negative 10. So maybe that's at least the first digit matching up. All right, so anyway, if I put 12 here and minus 2 here, now I need the correct amount of zeros. So if I put 2 zeros here, 2 zeros here, right? 1,200 times negative 200, that would be negative 240,000 because I have 1, 2, 3, 4 zeros here. There, I've got 4 zeros in my product. And sure enough, when I sum that, positive 1,200 minus 200, that equals 1,000. So I have the combination that works. So now I'm going to apply the ZPP, the zero product property, which states x plus 1,200 equals 0, or x minus 200 equals 0. And I'm going to solve these, which gives me x equals negative 1,200, or x equals positive 200. And since we were talking about dimensions, what did x represent? The amount you're adding on to the length and the width. I'm going to toss out this negative answer because it doesn't make sense in the context of the problem. It makes mathematical sense, but you can't build a field that has those dimensions. So now let's make sure we've answered the question. It says find the new dimensions of the field. So the new dimensions, if I add 200 on, would be 600 meters by 800 meters. Make sure you always answer the question asked and you have appropriate units attached to it. As you're working, watch your notation, okay? Don't get lazy. Make sure you have equal signs and you have things on both sides of your equal sign the whole way down. You have a rectangular picture that is 5 inches by 4 inches. You have 10 square inches of fabric that you want to use to add a decorative border of uniform width to the picture before framing it. What should the width of the border be? So this border is this white region in here, that's all the way around, okay? So this context of uniform width means if it's an inch around, it's an inch everywhere around, okay? So that's our unknown. That's what I'm going to label. And since I don't know that, it would be X on all 4 sides, or wherever I want to put that X. It's that same length, and that's the distance between the picture and the frame. And you have 10 inches of fabric that area needs to be. So again, there's a lot of ways you can think this one through. And after doing many of these problems, I instantly see this as a subtraction problem. So if I were physically present in front of you right now, I'd grab a sheet of paper and I'd have you think, well, how could I get rid of this inner area, right? If I took a scissors and I chopped this inner rectangle, I'd be left with just this outer border. And that outer border has to equal 10 square inches of fabric. So that's what I'm going to do. I'm going to take the outer area and I'm cutting away or subtracting the inner area, and I'll have 10 inches left over. So now I've put that into notation. The area of the outer rectangle minus the area of the inner is equal to 10 square inches. So let's express what we know in algebra. So this inner one, I'll label 5 by 4. Think about the dimensions now of the outer one. That's the trickiest part. So we know the picture is 5, but we don't know how much it's picking up over here. So it's gaining X inches on this side, but it's also gaining X inches on this side. So I could state that this side is 5 plus 2x, or I kind of like to always write my variable first, 2x plus 5. Similarly, the width, okay, would be originally 4 inches, but it's picking up X inches on either side, so it'd be 2x plus 4. So I'm going to multiply those two binomials together to get the area of the outer. And I'm going to subtract the inner area, which would be 5 times 4, or 20 square inches, and that's got to equal 10. So again, I'm going to put this all in standard form. How am I going to do that? I'm going to multiply these two binomials together, so that's FOIL or double distribute, whatever language you use. Pause the video and do that simplification. I can now see that I've got some like terms here. I can cancel the 20s, and I need to subtract 10. And now I have the trinomial in standard form, and since it's a quadratic, I am going to factor this, and I'm going to pull out the GCF, which appears to be 2. And now I'm going to try to factor this remaining trinomial. So I'm going to do some guess and check. You can do tic-tac-toe off on the side if you need it. So 2x and x are going to be my factors of x squared, 2x squared. And think about factors of -5. So I know one's going to have to be positive, one's going to have to be negative. I may need to flip that around. I'm going to put 5 here to get an outer product of 2x times -5 would be -10x. And I'm going to put a 1 here, because again, 1 times -5 gives me -5. I think I have a small issue. This is going to be -10 and positive 1 adds to 9x, so I need to switch which one's positive and which one's negative. So I'm going to make this one positive, and I'll erase this and make this one over here negative. All right, now I'm in good shape. I can apply the zero product property, which says 2x minus 1 equals 0, or x plus 5 equals 0. Slide this up a little bit. That gives me 2x equals 1 by adding 1 to both sides. Divide by 2 and x equals 1/2. Or over here, x equals, if I subtract 5 from each side, I get -5. I'm tossing this answer out because a negative frame makes no sense. Whereas a 1/2 inch frame, that makes sense. So I'm going to make a 1/2 inch border all the way around. Okay, last application. Looks like I'm going back to revenue. A monthly teen magazine has 28,000 subscribers when it charges a $10 per annual subscription. For each $1 increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? So revenue, again, is equal to your quantity or your number of subscriptions times the price for each one. And so I'm going to think about, normally they have 28,000 subscribers at the cost of $10 each. I'd multiply those two values together and get that my revenue is normally, what, $280,000. But if they change the revenue, or they change the price, for each increase in price, so 1x, where x is the number of price changes again, we've done these before, what happens to my quantity? The quantity will lose, so drop 2,000 for each price change. So I know my goal is to find the vertex when I'm maximizing revenue. So I'm going to have a parabola that's going to open upside down. I know that with revenue I'd end up having a negative a value. And I want this vertex, so I could certainly put this in standard form and do negative b over 2a. But I see an easier way. Since this is already factored, I could very easily find the value of these two x-intercepts right here. How could I do that? Well, the x-intercepts, what do they have in common? Their y value is 0. So if I plug in 0 for y, I can now apply the zero product property because this is factored. So I take the first factor and set it equal to 0, or the second factor and set it equal to 0. This one on the right is very easy. I get x equals negative 10, so that would be this x-intercept. And over here, if I subtract 280,000 from each side, and then I divide both sides by negative 2,000, I'm going to get x equals 14. So the second x-intercept is 14, 0. So how is that helpful? Well, I know that I can use symmetry to find the vertex. It's going to be halfway between negative 10 and 14. So my if I add negative 10 plus 14, that would be positive 4. Cut that in half, that's 2. So now I just need to find R of 2 to find the revenue. And I get 288,000 for the revenue. So now let's just answer the questions. So if you remember, your X value is your number of price changes, and this is your revenue. So the first question is, how much would the magazine charge to maximize the annual revenue? So I go to the price portion of the function, and I plug that in. I plug in X, so they should charge, it would be 10 plus 1 times 2, or $12 per subscription. And that's going to give you the maximum revenue, which we already got, the 288,000.